far as linear motion is concerned, there are some equations that govern that particular aspect of linear motion, right? So we look at the graphs. Now we are going to look at the equations, the actual equation that run that. So there are basically three equations of motion mathematically. I mean the mathematical expression. So what we are doing so far, we are starting from the basis, which is for linear motion. So remember, this is for linear motion, right? The equations of motion. Okay, so for those equations of motion, we need to know that we're talking about things like distance or displacement. So let me do distance or displacement. These are the things that will be of focus when it comes to linear motion. And then we'll be talking about velocity, right? Because it's on a linear motion, right? Sometimes velocity can just be speed, but then it's mostly velocity. We're talking about velocity, calling it velocity mostly for linear motion, right? Then we'll be talking about acceleration. Acceleration. So these are the three things that will be of major focus, and all this will be happening within time. So time will also be another factor that will be in the equation. So for distance, right, displacement, the symbol that we'll be using for displacement in this case is going to be S. I know you'll be thinking it will be D, but then for from the equations of motions, you have to keep in mind that it's going to be S. So we're using S as a symbol for displacement or distance. So in the velocity, we are going to be using V or U, right? When we say V, when we use V, we are just referring to final velocity, meaning the velocity at the end of the journey, or at the end of a particular section of the journey, right? So we are going to be talking about final velocity. When we are talking about initial velocity, it's going to be U. So U and V are going to be used in that case, right? For velocity, V for velocity, for final velocity, U for initial velocity. Those are the two that you need to keep in mind. Acceleration is going to be A. It's just going to be A itself, and time is going to be T itself. These are the ones that will be used in the equations of motions, right? Okay, the very first equation of motion, right? Equation one is going to be this relationship that we have V is equal to U plus AT. This is the first equation of motion, where V is the final velocity, as I said. U is the initial velocity, and A is acceleration, and T is time. Right, that's the first equation of motion. Another equation, and the next equation of motion is going to be related with distance, right? So it's going to be S is equal to UT plus half AT squared, right? So UT plus half AT squared. This is the second equation. This one relates the displacement to the initial velocity and acceleration, right? So we can see that in this one, we don't have final velocity in this equation. We only have initial velocity in this equation. There is no final velocity. So based on the various parameters they will give you in a question, you need to know the equations of motions and which one to use. And then the third one that we need to also know is V squared is equal to U squared plus 2AS. 2 times A times S. So this one, you can see that there is no time. There is no time in this equation, right? So sometimes they will give you the question, they will not talk about time at all. Then you'll be able to use this one to find, they'll give you distance and all that, right? So you can use this one to just find whatever you want if they all fall in the same equation. If they don't fall in the same equation, for example, if they are looking for time, if they are looking for time, right, and they give you final velocity, they give you this, they give you acceleration, you can get the distance. When you get the distance, then you go to the distance equation, you go to the distance equation to find time. Or maybe you can even, whatever you get from here, you can even go to this particular equation and use that to find time, right? But this equation does not have time, so there is no time in this one, and this one does not have final velocity V, and this one does not have displacement or distance. Those are the things that you need to keep in mind about the equations of motions, right? So we'll be solving questions around that in the next session, so that we see how to use each of them. But again, when you see something like this, v is for final velocity and u is for initial velocity, a is acceleration, and t is time. These are the three equations that you need to keep in mind, right? The linear equations. And this one, the first equation does not contain distance, so there's no distance in this one. Over here, there is no final velocity v in this one. And in this particular equation, there's no time in this one. So those are the things that are accepted in every equation. So that whatever they give you, whatever you have available, it will match one of them. And then when you're able to use one, you can find the others. Once you're able to use one equation, it can allow you to enter any of the others to find any other parameter that is missing in that particular equation. Your choice of any equation depends on the parameters you have available in the equation and what they are looking for. So we'll be solving a lot of questions in the next session so that you understand how this one relates very well. So right now we know the equations of motions and then we are ready to start using them.